Hi. Right, today I'm going to look at another type of what we'd call a real life graph. I mean, we've done the financial graphs. This is another type of real life graph called a distance time graph. And what we're really looking at is if I travelled for 2 hours and travelled 4 kilometres. So you see on my graph here, I've got time. So 30 minutes, 1 hour, 1:30, 2 hours, 2 hours, 30, 3 hours, and then kilometres up here, 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. So I've got 2 hours and 4 kilometres. Now that means I can draw a line between the two, and it wouldn't escape you to notice that that's directly proportional. So there's a few things that make it directly proportional. I mean, we know that it goes through zero, but the line is straight too. Now that's really quite a massive assumption when you are thinking about travelling, but what the straight line would mean or would assume would be constant speed. Now we can work with variations in speed, but at the moment with your age group and for the maths that you know and the coming maths that you're going to know over this next year, it's easiest for now to assume that constant speed and that idea of direct proportion, so that I can now use this graph to say, okay, in 1 hour I would have travelled 2 kilometres. Now, when I look at another type of graph, I might make something more involved. So rather than just that one straight journey, the journey might involve more steps. So in the first hour, I might travel 2 kilometres, and then I might go no further. In the next hour, I might stay there. I might stay somewhere for a cup of tea, although you're not allowed to do that. And that means I don't progress any further in distance, but time marches on for us all, I'm afraid. So time has to keep going. Now let's say in the next half hour, I travelled a further 3 kilometres. You can see that I am now 5 kilometres away from home, and maybe I would stay there for another half an hour. So I've got these places where I stay, and then I might think, right, I'm going to come all the way home. So strictly speaking, this distance here is the distance away from the start. And if you were a physicist and certainly an A-level mathematician, you would use the word displacement for that. Now, one thing I want you to notice about all of this is that not only have we got flat spots for where we don't move, but also that there are differences in the steepness in here. So here, in 1 hour I went 2 kilometres, but in here in only half an hour I went 3 kilometres. So common sense would tell you that I had to be travelling faster there. So a steeper graph means faster speed. So thinking about speed, maybe we ought to think about speed a little bit more. So say on this one I travelled 5 hours for 2 hours and I travelled 5 kilometres. Because that's directly proportional, if I'd have drawn this well, which I've not done a bad job of, So I've got 5 kilometres in 2 hours, but also because of the direct proportion within that, I've travelled 2.5 kilometres in 1 hour. And it'd be no surprise to you that we would, if we're assuming that we've got constant speed, that we would write that as 2.5 kilometres per hour. And you know, if I'd have travelled uh, 8 kilometres in 2 hours, you would say that's 4 kilometres in 1 hour. That's 4 kilometres per hour. And what we're looking at then is the whole idea that 4 we can clearly see comes from 8 divided by 2, and 2.5 comes from 5 divided by 2. So we've got speed is equal to distance divided by time. And there's your kilometres, there's your per, and there's your hour. Now, one thing I like to work on is something called the SDT triangle. And that's an example of an algebra triangle. And in an algebra triangle, that helps you with rearrangement really. So for example, if I said to you, I travelled at 5 kilometres per hour for 3 hours, how far have I travelled? Then I think it would be fairly common sense for you to say, okay, 5 kilometres per hour for 3 hours, I need to do 5 times 3. But from this point of view, I would say, okay, I want to find the distance, I'm going to scrub that out. These are on the same level, so they times. If they were on a different level, the line between them would mean a divide. Speed times time. So I'm going to do 5 times 3, which is 15 kilometres. Okay, so several things to look at there in a summary. A straight line assumes constant speed, so we might talk about average speed when they use that word, because obviously constant speed has to be an ideal. I can't see how we could travel anywhere at a purely constant speed, so we look at an average speed. From this one, the idea that we can have straight lines or horizontal lines which will give us places where we've stopped, not going any further away, but time marches on. Steeper lines mean faster speed because you are going a greater distance in a smaller amount of time. And then here, this builds up that idea that speed is going to be distance divided by time, and you can use the SDT triangle to work out various bits. For example, so if I wanted to find out how long something had taken, I would cover over the time and I'd go distance divided by speed. If I wanted to know the speed of something, that's distance divided by time. And if I wanted to know the distance, that would be speed times time. Okay, I hope that's clear, and I look forward to seeing you next time.